Good afternoon. My name is Satnam Singh, Assistant Professor in Chandigarh Polytechnic College, Kadua. Today I am making Zoom video on third semester automobile subject Basics of Thermodynamic, Hydraulic and Pneumatics. First will we see the learning outcome for student from this subject. Student will learn at the end of this course, the student will be able to explain the basic principle of thermal engineering, gas laws, laws of thermodynamic, air cycles, and air compressor. They also identifying component of hydraulic and pneumatic system. They also learn different modes of heat transfer like conduction, convection, and radiation. They also explain the principle of air conditioning and refrigeration, their components and functions. For syllabus, we have 9 chapters in this subject. First chapter is based on principle of thermal engineering. In this subject, student will learn thermodynamic property, intensive property, extensive property, their path, process, system, thermodynamic surrounding, heat and work, enthalpy and internal energy. In second chapter, student will learn various gas laws, Boyles Law, Charles Law, Joule's Law, characteristic gas equation, gas constant, universal gas constant. In third chapter, the student will learn zeroth law of thermodynamics, irreversible process, first law of thermodynamics, second law of thermodynamics, thermal efficiency and heat pump, heat engine and heat sink. They also learn concept of entropy and various constant process, constant volume process, constant pressure process, isothermal process, adiabatic process, polytropic process, throttling and free expansion process. In fourth chapter, the student will learn various air cycles like Carnot cycle, Otto cycle, diesel cycle, and dual combustion cycle. In fifth chapter, which is based on air compressor, the student will learn reciprocating air compressor, centrifugal compressor, working of single stage and double stage compressor and their application, rotary air compressor, working of fan, blower, booster, and supercharger. In hydraulic, sixth chapter is based on hydraulic. They will learn type of fluid, property of fluid, Pascal law, component of hydraulic system, function of each component in hydraulic circuit, oil reservoir, filter, seals and packaging, hydraulic jack, the principle of hydraulic jack and hydraulic press. Seventh chapter, which is based on pneumatic system, they will learn basic component and their function of pneumatic system, air cylinder, their functions, single acting and double acting air cylinders, air filter, regulator, different types of control valves, concept of automation. In 8th chapter, which is based on heat transfer, student will learn various modes of heat transfer, conduction, convection, radiation, and Fourier law. In last chapter, which is based on refrigeration and air conditioning, the student will learn refrigeration method, unit of refrigeration, refrigerant, definition of refrigerant, heat pump, coefficient of performance, rating of refrigeration machines. They also learn the air conditioning system, principle of air conditioning, concept of human comfort, introduction to air conditioning system, component of air conditioning system and their functions. My first topic is thermodynamic boundary. So what is thermodynamic boundary? And involved enclosing the system is known as boundary of the system. Every system has a boundary. The boundary is of various types. First is fixed and real boundary. For example, like pressure cookers, boundary is a fixed and real boundary. The surface of pressure cooker is the boundary for the system inside the cooker as the surface of the pressure cooker exists physically. So this type of boundary is known as real boundary. Second boundary is imaginary boundary. If the boundary does not exist physically, it is called imaginary boundary. We can just imagine a boundary, but it does not exist physically. Third thermodynamic boundary is moving and real boundary. When the boundary is not fixed but moving by piston cylinder arrangement, it is known as movable boundary. The example of moving and real boundary is piston cylinder arrangement. The next topic is thermodynamic system. According to the flow, mass and energy, there are four thermodynamic systems. So it is classified as, first system is closed system. It is defined as a system in which the mass enclosed within the boundary of the system remain constant, but energy in the form of heat or work transfer across the boundary of the system. The system is closed, but the energy in the form of heat or work transfer across the boundary of the system. In first figure show the piston cylinder and the gas contained in the cylinder is an example of closed cylinder, closed system. Second is open system. It is defined as the system in which both the mass and energy transfer takes place across the boundary of the system. In closed system, only energy can transfer, but in open system, both mass and energy transfer takes place across the boundary of the system. The figure to show the piston and cylinder with inlet and outlet passage where the gas enters the cylinder through the inlet port, expands, pushing the piston and doing the work. Third system is isolated system. When neither mass or energy transfer across the boundary of the system, then it is known as isolated system. In this system, the mass and energy remain constant where the body wall is thermally insulated. In closed system, the energy transfer. In open system, both mass and energy transfer take place the boundary of the system, but in isolated, neither mass or energy transfer across the boundary of the system. Fourth system is adiabatic system. In this system, no heat transfer takes place between the system and its surroundings, but the boundary of the system moves. The mass enclosed in the boundary of the system remains constant, but energy in the form of heat increase or decreases. So my next topic is gas laws. My first law is Boyle's law. It states that temperature remaining constant, the volume of a given mass of a perfect gas varies inversely as its absolute pressure. In gas laws, we have three terms like temperature, volume, and pressure. One is constant, another one is directly or inversely proportional to another one. If temperature constant, volume is inversely proportional to pressure. If pressure constant, volume is directly proportional to temperature. So these laws are based on these three terms: temperature, volume, and pressure. So in Boyle's law, it states that temperature remaining constant, the volume of a given mass of a perfect gas varies inversely as its absolute pressure. Let P is absolute pressure of the gas, V is equal to volume. Then as per this law, V is inversely proportional to pressure. So PV is equal to constant. Boyle's law in PV is equal to constant. Second law is Charles' law. It states that pressure remaining constant, the volume of a given mass of a perfect gas varies directly as its absolute temperature. So in this law, pressure is constant and volume is directly proportional to its temperature. So V upon T is equal to constant. V is equal to volume of a gas. T is absolute temperature. Next topic is first law of thermodynamics. According to this law, a definite amount of mechanical work is needed to produce a definite amount of heat. We need some mechanical work to produce a heat in first law of thermodynamics. Therefore, when mechanical work is produced from heat. A definite amount of heat goes out of existence for every unit of work done. And conversely, when heat is produced by the mechanical work, the same definite amount of heat comes into existence for every unit of work. So, mechanical work is directly proportional to heat. We need some amount of heat to produce mechanical work. If W is equal to mechanical work, H is equal to heat energy. So W is directly proportional to H in first law of thermodynamics. In second law of thermodynamics, mostly we are say law of conservation of energy. This law shows that the energy can neither be created nor destroyed, but converted from one form to another. Extending this law, it is stated that in all transformation, the energy due to heat unit supplied must be balanced by the gain in internal energy plus by the external work done due to rise in temperature. So energy can neither be created nor destroyed, but we can convert from one form to another. If dq is delta q is heat transfer, then delta u change in internal energy, delta w is equal to work done. So heat transfer is equal to change in internal energy plus work done. So second law of thermodynamics shows that heat transfer is equal to change in internal energy plus work done, or energy neither be created nor destroyed but converted from one form to another. My another next topic is AutoCycles and diesel cycle. First is AutoCycle and AutoCycle, which is based on petrol engine. And AutoCycle is an idealized thermodynamic cycle that describes the functioning of a typical spark ignition piston engine. The Otto cycle is a description of what happened to a mass of gas as it is subjected to changes of pressure, temperature, volume, addition of heat, and removal of heat. In Otto cycle, our ignition member is spark plug working. The Otto cycle or petrol cycle describe how heat engine turn gasoline into motion. Like other thermodynamic cycle, this cycle turns chemical energy into thermal energy and then into motion. So in Otto cycle, it turns chemical energy into thermal energy, then converted into motion. The Otto cycle describes how internal combustion engine work like automobile and lawn movers. My last topic is diesel cycle, which is based on diesel engine. And the diesel cycle is a combustion process of a reciprocating internal combustion engine. In it, fuel is ignited by heat generated during the compression of air in the combustion chamber, into which fuel is then injected. So we cannot use spark plug as a ignition member. So fuel is ignited by heat generated during the compression. So this is based on diesel cycle working. It is also known as constant pressure cycle because the heat is taken in at constant pressure, whereas the rejection is at constant volume during the cycle. Auto cycle is a constant volume cycle, but diesel cycle is a constant pressure cycle. So this is my PPT on basics of thermodynamic, hydraulic and pneumatic.